I'd like to introduce Astro-FLEX, which is software designed to explore your FITS files. It can be downloaded from chickadeeridgeobservatory.com, and there is a Linux version and a Windows version. When you first start up the program, you'll see an image that looks like this. There are 3 boxes: raw, calibration, and corrected, but these are really just placeholders. The software is not designed at this point to actually take raw images and convert them to corrected, meaning it does not do bias, dark, or flat fields, but it does do some post-processing steps such as background subtraction and alignment that I'll show you soon. At the top you'll see instructions. At the bottom there's a logger. Now the logger actually gives some useful information. First of all, you'll see that everything that's going to go into this logger region is also going to be written into a file on disk, which is called Astro-FLEX followed by the date and time, .log. Something else that I think is useful is it reads how much memory is on your computer, and the reason for that is because it's possible to load a sequence of images in each box, and you wouldn't want any problem with memory. So in my case, if I had images that were 4,000 by 4,000 in size, I could load up to 191 of them before I have any kind of an issue with memory, and in most cases I think you'll be fine. So let's load some images. So I'll go to the top left, and I want to load images in the raw, calibration, and corrected boxes. Let's start with the calibration. I'd like to load a single image, and the image is of M33, the galaxy. So here it's loaded. And when an image is loaded, first of all, here is 3D data detected, okay? That means that this particular FITS file had 3 planes of data, actually corresponding to red, green, blue, but the software will take the very first plane for display or for processing, whatever you want to do with it. It reads from the header of the file, and in this case we have name of the object, the RA and the DEC, the date of observation, the telescope, the exposure time, temperature. Quite a bit of information is then given to you from the header. It also calculates the plate scale, and it does this from the pixel size and the focal length, which are in the header. So in this particular image, I have 0.39 arc seconds per pixel. Also, any image that is loaded will automatically have its statistics calculated. So by that I mean over the entire image, it calculates finds the minimum, maximum, calculates the mean, median, etc., and all that information is given to you. So let's load a couple of other images. In the raw box, I think I'll just load a star field, and in the correction box, I will just load another star field, but I've changed my mind, so I think I would like to reload in the corrected box something else, so I'll simply redo it and it replaces what was there before, so it's not an issue. In this particular case, the right-hand box contains a radio image of a galaxy NGC 660. It has a little disk along this way and a very bright nucleus because it has an active galactic nucleus. Now, because it's a radio image, it has somewhat different information in the header. So in this case, again, it gives the name of the object, RA and the DEC, date of observation, etc. But now it will also give you the beam information. So that would be major, minus, and minor axes and position angle of the beam. The beam specifies the resolution of the image. It also gives you that in this particular case we have 1 arc second per pixel, and again it gives the statistics. So let's explore a bit. Let's take a look at M33 in the middle. I can click for a log scale or back to a linear scale, but I think I'll click to a log scale again. And on the right of each image there's this black vertical scale here. If I hold down my left mouse button and move it, I can move the entire scale up or down. I can also expand the scale, so I'm now using my mouse wheel And I'm stretching out that scale, stretch out with using the mouse wheel. And there are handles here, little yellow handles at the bottom and at the top, and that allows me to change the brightness scale. So I'm adjusting the scale right now for this particular image. Now suppose I want some color. So I've got the cycle color here, and it does exactly that. It cycles through different color schemes. And I could change the scale as well. If I went to the right over here again, I can change how that looks. But I think I'm going to stop soon. Okay, back to black and white. So let's stop at Inferno, because I kind of like this one. Now, I can explore this a little more. So using my mouse wheel, I can zoom a bit, and then holding down my left mouse button, I can pan. And if I sort of forget where I am, I can just reset the zoom back to where it was originally. Suppose I want to expand this even more. If I double click on the left mouse button, then I can get an enlarged view of the image. Again, I can use my mouse wheel to expand it or contract it even more, and I can move it around with my left mouse button. If I hit escape, I go back to the original. Now, what about the numbers? You'll see that as I move my cursor over any given image, at the very bottom left of the main window, the large window, you'll see some numbers in red, X, Y, and a value. And so what this does is it reads the X and the Y position of wherever my cursor happens to be, and the value at that pixel position in the units that are actually in the header. Okay, any image will do that. Now, what about this red box? The red box is called a region of interest, or ROI, and if I move my cursor into it, hold down my left mouse button, I can move this wherever I want. If I double click inside it, then I get the statistics of everything inside that box. I might want to change the size of the box, so I would grab the top left corner, there's a kind of handle there, or I can grab the bottom right corner and I can change the size. If I double click on it again, then I get the statistics. So now we're going to do some quick processing. Let's take a look at the raw box again, and I'd like to do a sequence with background subtraction. You'll see it says writes files to disk. Why? It means that every image that's going to be background subtracted is written, the background subtracted version is written to the disk. So it's image by image in a sequence. So let's click on this and you'll see what I mean. So let's go to a sequence of images of the same region in the sky. If I open it, now every second a new image in that sequence is loaded. So the left box shows the non-background subtracted image, the center box shows the background, and the right box shows the corrected image, and at the very end it gives me the median of all those corrected images. You can see it's really streaky, and that's because the images are not yet aligned. So if you go back down to the logger and you were to scroll up, you'd see the names of the individual files that have been background subtracted, and they have BG sub prepended to the file name so that you know that they are background subtracted values. If I were to scroll up a little further, I give you a link to a URL that explains more adequately exactly how the background subtraction is carried out. Finally, I'd like to do one more example, which is of alignment. So if I go to the raw image and I do sequence with alignments, again it's going to write files to disk. Now I want to take all the background subtracted images that I've just made, and I'd like to open them, open the sequence, and again it steps through the sequence of various non-aligned images, and at the end it's going to give me the aligned image over on the right hand side in the corrected box. Now you can see it's not streaky at all. It's all aligned very nicely. Again, in the logger box, you can see the names that are written image by image. They're called align, BG, sub, etc. So you know that these images now on disk have been aligned and background subtracted. Again, if you were to scroll up farther, there's a link to the URL which explains more adequately how the alignment is actually carried out. In this case, each file, I at least give you the delta X and delta Y values. So every image is being aligned to the very first image in the sequence, and then you can see what delta X and delta Y are in pixels, the alignment that was actually required to bring this nice clean image up on the right hand side. So finally, all we want to do is save something. Let's say I want to save the median of the aligned images. Let's make it color for the sake of it. If I do a right click, you'll see an export. Up it comes. I can name the file what I want to. I can save it as a FITS file, or I can save it as PNG or JPEG. But the PNG or JPEG will be saved. What will be saved is exactly what you see, and that includes this red box. So I'm just going to cancel that. So say I like this color. Let's say I'll leave it like that. So I like the color, but maybe I want it to be saved as a PNG without this red box. If I double click, I'm going to get the expanded view, and now the red box is gone. Right click, export, and I can save the nice clean image. So that's it pretty much, and thank you very much, and I hope you'll find this useful to you.